In this problem, we're given the equation form of a function, and we are asked to approximate the x-intercepts with a graph, then find the x-intercepts, also called the roots. The question might state this as find the roots of the function and compare them to the approximations. So first thing we'll do is we'll take this and we'll go ahead and make a graph. The approximations, what we're looking for here is where is it crossing the x-axis? Well, there's something close here to -2, something close to -1, 0, 1, and 2. And it might be those numbers, but we don't know for sure. It could just be something really close to them. That's why it's an approximation. Once you've graphed it, it gives you a good idea of what you're looking for. Something that you can also check is looking at this. It's crossing 1, 2, 3, 4, 5 times, and this is a 5th degree polynomial. So that tells us, yep, there's 5 different solutions that we're going to be looking for in this particular problem. To start off finding them, the first thing you want to do is just set it equal to 0. Because what that says is what x values would give me a y value of 0. And of course, that's where it's crossing the x-axis, where we have y values of 0. Then after that, factoring is typically the way you go about doing these. There's really not a short way to do this other than just doing the factoring. So I'm going to look for my simplest type of factoring, which is greatest common factor factoring. There is an x in every term, so I will go ahead and take that out. If there was a constant or a coefficient I could take out of each one, I would also factor those out. I take out my x, I factor it out, and I already know one of my solutions. Because if this times all of this is equal to 0, then either this one's a 0 or this stuff is a 0. If this is 0, then that's going to be one of my solutions. So, and that actually goes with my approximation right there. So I've got that one. That one's done. I'm looking for 4 more. I am looking at the degree here or the graph. Either way, I know I've got 4 more to look for. Again, I'm going to go with factoring. Greatest common factor is done. Now I've got trinomial factoring I can work at here. A lot of people struggle with trinomial factoring. Here's a little trick to keep in mind. If the second sign is a positive, you know that when you break it into 2 expressions, they're both going to have the same sign. Then look here, what is the same sign? It's going to be negative. So I know they're both going to be negatives. This tells me they're going to be the same. This tells me what they're going to be. If this was a negative, I would know that there would be 1 positive and 1 negative. So that's a little trick to help you with factoring trinomials. So I go ahead and I factor that. Again, there's those 2 negatives I talked about. They're both the same. They're both negative. Factors it x squared minus 1 and x squared plus 4. There's a little bit of guess and check there. Not too much to come up with this because I knew I needed 2 things that when I combined them they gave me a 5, but when I multiplied them they gave me a 4. Well, there's not a lot of options to that. It's going to be a 1 and a 4. Well, that only gives me what appears to be 3. Well, there's still actually 5 total here because I've got an x squared term and an x squared term here. I'm just not done factoring. Here I can factor using difference of squares. They're both perfect squares. This is 1 times 1 is still 1. Same here, difference of squares. A 2 times a 2. So I can use my difference of squares factoring, and I end up with this. Now I've got 5 different expressions, all multiplying together to give me a 0. So you just go through every different expression. What would make that one a 0? Of course, a 0 here, we talked about that. A negative 1, a positive 1, a negative 2, a positive 2, which matches with our estimation. Actually, it lines up perfect. Tells us our graph actually was right on those. There were no decimals involved. We don't know until we're done at this point if there were actually some really close decimals. But there's not. So here's our solutions. When x is 0, negative 1, positive 1, negative 2, or positive 2. Those are our roots or our x-intercepts.